This is part 2 of section 2.2. We are now dealing with compound inequalities. On all of these problems, we're going to have two inequalities given, and we will either have the word and or in the center. If it's and, we are looking for the intersection of those two graphs. And if it's or, we're looking for the union of those. It's an inequality, so we will be graphing, we will be shading, and we're also going to be giving our answers in interval notation. Okay, now on the majority of these problems, you're going to have things that are more complicated than these. So you're going to need to rearrange and everything like we did on the earlier problems in section 2.1. This is simple because I'm going to show you how to deal with this part. The easiest way to do this is to graph each of these, one on top of the other. Like this is going to be my first graph, and I need a 5. For my second graph, I need a 0. And the main thing you want to have happen is if you imagine squishing these together, I want my numbers to be in order. So I don't want to put a 0 over here. So if I squish them together, 0 would be larger than 5. Just make sure things are in order once you push them together. Okay. Now what I'm going to do is I'm going to graph this one on this graph. It's going to have parentheses because this does not have an equal to on it. And I'm looking for numbers that are smaller than 5. So that's going to be in this direction with parentheses. Okay. Here, I'm going to have parentheses because it's just a greater than. I want my numbers to be larger than 0. So parentheses and shade in this direction. Okay. So this much I would do no matter what the word in the middle is. This is and, so I'm looking for the overlap. So I'm looking for the numbers that are in both. So we're looking for the stuff that is double shaded. Imagine pushing these together, and where would they overlap? Between these two values, correct? So my answer graph is between 0 and 5. Each of these had parentheses, so I have them here. And my answer is between 0 and 5. Now this is bounded. It's kind of like the three-sided problems we worked in the last section. So interval notation is really easy. You just pick them up off of here. Your left boundary is 0, your right boundary is 5. Each of these had parentheses, and you're done. Okay, so let's try a harder one, ones where we have to rearrange some things. So I'm going to graph each of these, but first I need to get x by itself. So for this one, I need to add 8 to both sides. So that gives me 7x is less than or equal to 56. Now I should divide both sides by a 7. And I get x is less than or equal to 8. Okay, so I'll graph this one in a second. Here, I need to divide both sides by a -4, but since it's negative, I need to flip that sign around. So I get x is less than or equal to 6. Okay, so I'm going to come over here and I'm going to do my two graphs. I need an 8 on one and a 6 on the other, making sure they are in the correct order. Each of these is going to get a bracket because they both have equal to's. All right, here, for this one is a bracket, and I want my values to be smaller than 8. So those are to the left, and a bracket there. Here, I want my values to be less than 6, and it's also going to have a bracket on it. So it looks like that. Now I look at the word here, and. So I'm looking for the overlap. If I push these together, the area where they'd be overlapping would be here going in that direction. Okay? So this area, even though it is a solution to this one, it does not work in this one, and I'm looking for values that work in both. So my answer is essentially this bottom graph. 6, you shade to the left. And that's because all of these values are also less than 8. So all of these meet this requirement as well. So that's my answer graph. My left-hand boundary is negative infinity. My right-hand boundary is a 6. Infinities always get parentheses. The 6 got a bracket, so it has a bracket. Okay, now for an OR problem. Again, I started off fairly simple so we can see how an OR works. We don't have anything to solve here. So I'm going to go ahead and graph both of these. Both of these have equal to's on them, so they're going to be brackets. And I have a 1 and I have an 8. Here I want my number values to be larger than 1, so I'm going to be shading to the right. Here I want my values to be larger than 8, so again I shade to the right, and it also has a bracket. Okay, so that much is done. Now we're looking for OR. OR, I want the answers to this one. I want an x value that works for this one, or works for both. So for OR, we pick up anything that is ever shaded. So where is this shaded by at least 1? From here up, correct? This is shaded once and everything else is shaded twice. But since it's OR, anything that's shaded at all is part of my answer. So my answer graph starts at 1 with a bracket and shades to the right. So my answer in interval notation, my left-hand boundary is a 1, my right-hand boundary is infinity. Bracket by the 1, infinities get parentheses. Okay, so let's look at this problem here. This is also an OR problem, and I have solving to do here. So for the left one, I want to subtract x from both sides. So I get 2x is less than 12. Divide both sides by 2. And we get x is less than 6. Okay. Here, I need to add 8 to both sides. So I get 3x is greater than 18. Divide both sides by 3. And you get x is greater than 6. Okay, this can be a very tricky problem because if you're not careful, you will think that everything is part of your answer and it's not. Okay, so the number I need to see on both of these is 6. Both of these will get parentheses as well, and that's actually critical. For the top one, I want my numbers to be smaller than 6. So those shade to the left and get parentheses. Now what the parentheses are actually saying is that everything that is shaded works, and what is shaded is all those numbers up until 6, but not including 6. So 5.99999, as long as you can imagine, was part of the answer, but 6 is not. Now right here, we want our numbers to be larger than 6, so that's shading in the other direction, and it also gets parentheses. Okay, so now we've got it graphed, now we look here. The word is OR. So we want to pick up everything that was ever shaded, everything that was ever part of a solution for either one of them. So it's going to be all of this and all of this, but not 6. 6 is not part of the solution here. 6 is not part of the solution here. So 6 is not part of this solution at all. So our answer graph, I need 6, and it's going in both directions. looks like this. 6 is not part of your answer. Okay, so how do we write this in interval notation when we have a jump? It's just a number, just one digit, one number we're jumping over. It could be a bigger gap, but if you're skipping over anything, you have to write your answer, and you're going to use our set operation symbols. Okay, so what I'm going to do is I'm going to describe this region first. It starts at -infinity, and it goes up to 6. Parentheses, parentheses. I'm going to leave myself a little space right here, and then I'm going to describe this part. Well, the left-hand boundary is at 6 with parentheses, and it goes to +infinity. Okay. Now, I do have a jump, and the way we do that is we deal with each part, we describe each region, and then you put, that's OR, so you put a union between them. This is your graph answer. This is your answer in interval notation. When you're working on the homework, this will pop up in the tool palette.